Hey, Hoon, how you doing? Hey, Hoon, how you doing?
Hi, how are you doing?
Hey, Pavel, how you doing?
Quite good.
Hoon, can you hear or speak? We might be having audio issues. Let's just give Hoon a couple of minutes to see if he can sort things out. Because it'd be a great shame if we can't hear him today. No, maybe we're good now. You're muted right now.
Hello, can you hear me?
I think he had some
Yes.
internet problems, but
Yeah, my internet kicked me out for a moment there, but I'm back.
No problem, Hoon. Where are you calling from today, Hoon? You're kind of all over the place usually.
Yeah. This time I'm calling from Munich, my home base. Although, last week I was in Japan for the
It's a rare
Astar
moment
location.
to catch Hoon at home. And Pavel, where are you calling from?
I'm actually now calling from Turkey.
Oh, awesome. Well, thank you very much, guys. Good morning, good day, good afternoon, good evening, good night to all that's listening. This will be recorded for later purposes, but a warm welcome to everyone to this episode of SubQuery Sessions. And today we're talking about everything related to WASM or WebAssembly. It's quite a technical conversation. I'm really looking forward to digging deep. And it's been one of those kind of concepts that a lot of people in Web3 and crypto and Polkadot even might not quite know all about. What is WASM? What does this four-letter acronym mean? Why is it the next big thing? And today we've got two really special and really really smart guys in the space who kind of specialize in this to kind of walk us through exactly what WASM is, exactly what it's here to solve. And without further ado, I would like to introduce our guests, Hoon and Pavel. Hoon, do you want to start by introducing yourself and the project?
Yeah, sure. Thank you. So, hey everyone, my name is Hoon Kim. I'm the CTO of Astar Network, and Astar Network, we are one of the bigger parachains within the Polkadot ecosystem. We also have a Kusama parachain called Shida Network, which is like the rebellious sister of Astar. And we are a smart contract platform. We focus on both EVM and WebAssembly smart contracts. So we were trying to remove the language barrier of smart contracts that's introduced by EVM by using WebAssembly, and we also have XVM, which allows smart contracts or dApps to interoperate between EVM and WebAssembly. So we're trying to open up the gates for the future of dApps for the general public.
Excellent. And Pavel, do you want to introduce yourself and Gear Network?
Sure. Actually, just would like to say first of all, guys, if you want to really have a technical conversation, I'm more of the ecosystem part, but I would like to do my best here to explain you what actually and answer the questions that you can have. From the other side, Gear actually is also a smart contract platform, but we're taking a little bit a different approach from what Astar is doing. What we decided to do is we decided to take something that was actually existing a lot in the Web2 space that was called the actor model. It was used for parallel computation and put it into the blockchain space, meaning that our messages and the whole idea inside of Gear is actually using the actor model, which allows asynchronous messages and parallel computation, which can even speed up more the WASM the blockchains that are using WASM or WebAssembly virtual machines.
Excellent. Well, why don't we take a step back, Pavel? Maybe you can start. Let's go right back to the start. For those people out there that have no idea what the hell WASM is, right? They've heard it been mentioned a few times in different groups, but they don't know anything more than what the full acronym is. Do you want to just try to explain to everyone here, like, what is WASM? What does it mean? Just make it kind of clear.
Okay. The idea WASM, the acronym means WebAssembly Virtual Machine. It was something that actually was invented not for the blockchain space. It was invented for browsers, and it was invented by big companies such as actually Oracle, Apple, Mozilla. They were trying to find the way how to make more efficient the upload of programs and into the browser interfaces, the graphics and stuff like that. So later on, actually, as we know, one of the first virtual machines was built by Gavin Wood for Ethereum. That's called EVM, or Ethereum Virtual Machine, which used a specific language called Solidity for programming there. It's like a derivative of JavaScript. So when Gavin decided to build his own, let's say, blockchain, the idea of Polkadot was arising there. He understood that actually using WASM could be much more sophisticated and interesting way than using the Ethereum virtual machine that was like the main agent at that moment. So that's why we have Polkadot, Kusama, and all the substrate things working on WASM. Plus, it gives you the option to speed up a lot the processes using additional normal languages, because there is another point that to WASM there is a lot of languages that are compiled, such as Rust, C++, and another 10 languages, programming languages that are actually sustainable, that are good and bulletproof, and proven that you can build difficult and interesting programs on that. So that also helps a lot to speed the processes because they're using less memory, they're more efficient, and they're more bulletproof.
Okay, so it's a new execution environment made for kind of general purpose computing, but also applicable to Web3. Hoon, is there anything you'd like to add to that kind of definition, that introduction?
Yeah, sure, of course. I think Pavel did a great job at introducing what WebAssembly virtual machine is. And I'll try to go back and talk about WebAssembly as just a normal technology, nothing to do with blockchain, but why it's effective for blockchains. So first, as Pavel mentioned, yeah, it's for the browser, but what is the problem that the internet had, and how does WebAssembly solve this? So traditionally, browsers generally would operate through the JavaScript virtual machine, which is its own execution environment that's it's embedded directly in the browser. But the problem is this introduces so much overhead because JavaScript virtual machine itself was not really meant for a high computation. It was just meant to manipulate the DOM, or the document object model, i.e. HTML in your browser, and just to make some shiny effects. But as browser use cases are increasing and people are making some really funky stuff in their websites, it requires more computational power. And we also need a more common ground, a common execution environment that other languages can compile down into. Think of it as like an assembly environment, but we need that for the web, hence why WebAssembly. And with the Java virtual machine, or JavaScript virtual machine, it's only meant for JavaScript, and you have language like TypeScript, which transpiles down into JavaScript to execute in this environment for a better language support. But still, it's pretty impossible to execute any or to build applications or high performing applications in any other languages because of this. And WebAssembly itself is just a message standard, and the WebAssembly virtual machine is a stack-based virtual machine, meaning that it has instructions in a form of bytecode that will execute within your system. And the way how WebAssembly works is, if by having like any not smart contract, sorry, any programming language compile targets a WebAssembly bytecode, it can actually create instructions for the virtual machine, which then can be executed on executed in an environment that is closer to the device hardware. So with this, you can actually create, use or execute like really wacky, high-performing complex applications in this browser environment. And this WebAssembly itself is just a standard. It's a message standard and a common execution environment, which is the WebAssembly VM. And this can actually translate with the same principles to blockchains. So imagine EVM as like the JavaScript virtual machine of blockchain, and Solidity as the JavaScript of smart contracts. And this works for a very specific purpose. It was meant, and the entire language and the architecture is meant to be like a POC made by Gavin Wood, like in a weekend. So it wasn't really meant to do anything complicated, and it is very limited when it comes to building applications with any other languages, because you have to, because EVM is not a common, well, EVM bytecodes are not a really common standard that other languages can target towards, while WebAssembly is. So this means that it opens up so much potentials. So you can basically translate the benefits that WebAssembly has for the browsers, but now we can translate that into the blockchain space and opening up so much more opportunities for the future.
So those kind of key reasons why this was such a big deal for running in browsers on people's computers to build really awesome applications also mean that it's a really good tool or language or kind of execution environment for blockchain as well, right? Because it's portable, it's very efficient. But also one thing you mentioned there is that you can code in any language. This might be the demise of the Solidity programmer. You can use very simple JavaScript.
Pavel, you want to comment on that, or should I?
No,
sure, either.
Comment on that.
Right. Well, so yeah, James, you mentioned like the demise of Solidity. Well, I wouldn't say so, because it's a language, right? There are compilers for Solidity that targets WebAssembly, meaning that you can actually create WebAssembly smart contracts using Solidity. There's also the EWASM project, which tries to introduce the EVM virtual machine within the WASM environment, which is like a virtual machine inside a virtual machine. So the performance is quite horrible, but still it has the compatibility layer there. So yeah, like Solidity won't really die. It's just like the way how we execute code is going to change, and it really opens up opportunities for other languages to come in.
I think that.
Oh, go ahead, Pam.
Yeah, I think that also the point there comes that if we can see, Solidity is like a language that was actually like invented for specific reasons and for specific virtual machine. Plus, we can see it in the normal programming languages. There is a lot of languages that are used for, and we can see that the evolution of JavaScript, TypeScript, and we see now Node.js, another type of languages that's used for web browsing. So actually, the same is coming here. Like we can understand that the use, for example, of Rust is much more efficient and working with WASM, for example, than trying to compile Solidity code into WASM. But the point is that both of them works, and then the efficiency is, let's say, the name of the game, depending on what you want to do, how fast you want to get executed, and how actually easier. In certain way, it would be easier to use Rust for program on WASM rather than to try to compile Solidity into WASM. But it's my opinion, to be honest.
Yeah, no, and it's fair enough, right? Like, but so we look back at the history that we've come from, right? Where the predominant coding language for smart contracts for a long time has been Solidity, and you've kind of put that into an EVM, whether it's on Ethereum or even on other networks like Astar, and you've run that way. What are some kind of like lessons, or what were the shortcomings of EVM that kind of caused a lot of the development of WASM, or that has kind of accelerated the development and growth of WASM out there?
I think that one of the best things that actually, it was more even the architectural idea that Gavin put into the Polkadot, that you can put the WASM code inside the blockchain, where it actually allows you to make forkless relay updates or runtime updates, where you don't need to fork the network, you don't need to have any decision maker on top of that, which actually accelerated a lot the whole idea of working with the blockchain, so you don't have some problems that we had before. Plus, I think that obviously the speed that it gives you and the efficiency is much bigger. Actually, I think even Vitaly Buterin, like 5 months ago or 6, put it into the tweet that if he will be rebuilding Ethereum from zero, he would be use a different virtual machine rather than Ethereum 1 that would be quite similar to what WASM is doing.
Right. And I'll also comment on that. So what are the shortcomings of EVM and how WASM is like improving on that? Well, first, I think I want to clarify certain definitions here because we are using the term WASM for like pretty much everything here. And if we look at a technical perspective, there's a couple of nuances when we're talking about WASM, especially in the substrate area, because I think Pavel touched on this forklift runtime upgrades. That's the WASM environment for substrate. So substrate itself is compiled down to WASM, and of course, like all the blockchain, entire blockchain is run within the WASM virtual machine. That's how we're able to achieve so many things here. It's flexible, it's unified, but there's also a different perspective of WASM, and that is WASM as a contract execution environment. So runtime execution and contract execution. In the end, I mean, they're like all executed from the node, so it won't really be much of a difference. But that's also like saying everything runs from the processor, so everything's a processor, right? Or everything's an instruction, a CPU instruction, which is true. But the point here is WASM for substrate is a little bit different. You should have a different perspective compared to how it's when we're talking about like in comparison of EVM, because EVM is a smart contract execution environment, not a node environment necessarily. So what's the difference here? So WASM for substrate allows so much flexibility and run forklifts, upgrades. I think Pavel mentioned all the good stuff. And WASM as a smart contract execution is more about, and I think I touched this in the previous point, it opens up language capabilities because you can compile various languages down to a single target. Of course, substrate, it also applies to substrate too, technically speaking, but for smart contracts, it's a little bit more, I would say, like accessible and universal compared to literally programming a runtime code, because you don't want to have your substrate node source code written in multiple languages. You just want to unify them to Rust, right? Well, smart contracts, they don't have that limitation. So even if the node was built using Rust, you can still use assembly script or C++ or C Sharp, hypothetically speaking, as the smart contract language, because it compiles down to the WASM binary, right? And back to the point, like what's the shortcoming of EVM? It's really that EVM bytecode is, well, EVM itself is a virtual machine inside a virtual machine. If you look at the substrate architecture, so much overhead involved in it. It's hard for it doesn't the node cannot perform well as just having pure WebAssembly environment. Another problem is that it's in the context of substrate, it's in its own environment, both syntactically and also execution-wise, meaning that if you want to have full EVM capabilities, you need to comply with the EVM RPC and methods, and you also have to comply with the Ethereum account scheme, even though substrate has its own account scheme. And if anyone who uses Astar will know that we support both account schemes, and this is a UX nightmare, but also functionally we do not discriminate towards a certain account. And this, of course, it's a double-edged sword. And I guess you can also mention like with EVM, it's hard to extend the language because you have to build an entire compiler from scratch if you want a certain language to support EVM. While WASM, it's more general. It's widely supported by various like big companies, so you can definitely guarantee that technology is gonna evolve way further than we can ever imagine. While EVM itself is in its very closed bubble. We say like Solidity and EVM is the standard of blockchains, but imagine like even those the programmer of Solidity it's not even like a fraction of the programmer of Rust, like the Rust programmers. The audience is really small, and we're living inside our own bubble. And I think WebAssembly sort of opens up that gate to the broader audience.
Yeah, that's a good point, because I've heard a few times people saying EVM and Solidity, they're kind of like the JavaScript of blockchain programming. Like everyone kind of hates it, but because it's so standardized and so common and everyone knows it, it becomes kind of the de facto. You're kind of saying that because WASM is so much more generic and it's used widely in other ecosystems and other industries outside of Web3, you think that will kind of be a big reason for its adoption coming through in the future?
Absolutely.
Actually, there is some statistics that we were collecting regarding that. Is that we have around 18,000 commits each month, something that is related to blockchain space in the GitHub, crypto and blockchain together. And we can see that there is around 2.2 million developers that actually are coding on Rust. And there is about 20 million developers in the world that's actually are coding in languages that are compilable to WASM. So that's true what Hoon is saying. Like, I feel we are now still in the blockchain space. We are living like in a small bubble of people that actually rotating from projects into projects. And one of the whole ideas also of Gear is actually to open the door to these developers that are used on the Web 2 and still didn't come to the Web 3 space.
So talking about languages out there, there's this language that we commonly hear with WASM, and that is ink, and ink with an exclamation mark. What is ink, and why does it have an exclamation mark?
All right, well, that's a good question. Well, ink is an EDSL of Rust. EDSL means that it's short for domain-specific language or embedded domain-specific language, meaning it's still Rust. It's still Rust, but it has its own like framework and syntax sugaring that makes it specialized for a specific purpose. You can just sort of imagine this as like a framework of JavaScript. Like, I mean, okay, technically speaking, it's incorrect, but in terms of like just imagine, just for illustration purposes, like it's, I guess you can say EDSL or ink is like what React is for JavaScript. It's meant for a specific purpose. And the exclamation mark, actually, that's a good question. I always like just took that as like some sort of like a joke. But if it's a technical joke, then the exclamation mark should be before the ink instead of after the ink. So yeah, I could probably I might actually have to ask Hernando and Michi for that. Why they did why they named it
I
like
just
that.
assumed you had to shout it from the rooftops when you said the word. You know, it's probably a marketing exercise, right? Whenever someone says it, they have to really yell it.
Yeah.
And everyone in the room's like, "What the hell are they talking about?"
Yeah, but I mean, the funny thing is like because it ends with an exclamation mark, no one actually puts that exclamation mark when they're writing because it really does mess up your you're not IntelliSense, your spell checker.
It certainly doesn't help with like SEO and Google searchability.
Oh yeah, it's horrible. I mean, the language is good, but like the naming, it's really funny. But anyway, so yeah, Ink is it's a it's an EDSL for writing smart contracts with Rust for the parity contract palette, which is a contract execution environment that is developed by Parity, and it's a flavor that's specifically built for Substrate. You can think of it as like it's like another alternative of Gear. Gear is its own environment that's separate from the contract palette.
Yeah, Pavel, do you want to talk about that?
Yeah, sure.
What?
Yeah, actually, that's true. We don't use ink as a contract palette. We develop our own one. First of all, we're using asynchronous messages, so it's a little bit different the type of execution how it's done in ink. Secondary, what we decided to do is we decided to build a little bit different way, so we don't want to make domain-specific features into the language. We just practically, thanks to the actor model, the two things that you have to be managing is the message that you are sending to the contract and the message that you're receiving as a person that is writing there. So if we talk a little bit about what the actor model is that everything inside the blockchain becomes an actor, meaning it doesn't matter it's a user, it's a program, it's a bridge. Everything has the same wallet and the messaging system. So they communicate between themselves through messages. And this allows us actually to make it more easy to the normal developers to come into the blockchain space because they basically can have the same logic that they would be having if they would be coding a normal program.
Okay. So you're trying to provide a really kind of familiar environment, but also very optimized for WASM.
Yeah, the idea is to make, obviously, if you want to go deep and to be like professional in Rust and stuff like that, you can go deep into the syscalls, what's called, and take out all the libraries that you put on top and program it like from pure zero part. But the whole idea is that even if you are not an expert in Rust, you can quite easily go and code your application or your D app by using normal syntaxes, actually, without domain-specific features.
And
Okay.
I also want to touch on asynchronicity in smart contracts, because I think that the actor model of Gear, and I believe Cosmo has also used the actor model, but yeah, that's what I believe. Asynchronicity in smart contracts is what I believe to be the key feature for the next big step for Web3 adoption. Not just adoption, but also like applications and use cases. Because well, first EVM it does not support asynchronous functions like at all, and I'm pretty sure there are ways that people can like just hack it around to sort of give the illusion of that, but officially it's not supported. And this is also the case with ink and the contract palette. Asynchronicity is still like really finicky, but with in a world where multi-chain and cross-chain operations are common, and for composable XCMP functions, I believe asynchronicity will be one of the key components of this. And that's why we're also looking into a lot of ways to enable asynchronicity in ink, also in by extension the contract palette, because Rust, at least syntax-wise, it does supports comprehensive asynchronicity and fearless concurrency. So it is possible. Like it's just a matter of like how do you wrap this around, and as Astar Network is a multi-virtual machine, where you are not limited to the contract palette. We could actually look into another virtual machine like Gear, or even Cosmo as an implementation for Substrate, to enable asynchronicity functions, so that smart contracts they have more power when it comes to interacting with other blockchains, and other extending their use cases for more efficient and more effective smart transactions.
So I'm just going to take again this a step back. Asynchronicity is something that comes up a lot, right? And for us developers, we kind of understand it. But asynchronicity is this concept of being able to run a program or do an action and kind of wait a semi-indeterminate amount, or wait a period of time for the result to come back. And in computers, it's quite weird because computers kind of expect things to happen in sequence in a predictable order. Asynchronicity is kind of pausing and holding off, and it's quite interesting it's quite a tricky thing for blockchain, because in Polkadot, for example, you might send something to another chain via an XCM message, and you might have to wait an indeterminate amount for that other chain to act upon it and then to return a value to that. So in terms of the asynchronicity with WebAssembly, what will that kind of enable in that micro level? Is there any kind of example use cases for those people here that don't kind of live and breathe these terms every day?
I can give one example, for example, that we're actually playing a little bit with that around, especially for the guys of Gamify, for example, who have been just last week on DevCon, and you will see mainly the Gamify or games that are actually done on the blockchain, and they were doing something like a strategy. Then it's actually happening that everybody, let's say, if you're using a normal way of virtual machine, that everybody has to make their own move. Then you have to wait till the last one is finalizing it, and just after that, the whole computation could be done, and you can see the results. So if we're using asynchronous messaging here, so actually each one of the players could be playing by themselves at a certain moment without waiting the others to make their move. And then at the end of the result, you can have the final game pretty similar to what you're having in normal computer games.
Well, Pavel just stole the example that I wanted to say. But okay, so I guess I can give like an illustration of how asynchronicity in blockchain looks like for the non-technical people. So traditionally in a smart contract, when you sign a transaction or when you interact with a smart contract, all the operation goes into the blockchain as a thing, and then the results are expressed after when the block is finalized. As in, like it's every interaction that you make for a smart contract will start and end in a single block. It's there's no exceptions. But in asynchronous smart contracts, you can actually make an interaction in block A, and then you can actually get the results at block B, or so. So it's not limited to a single block. You can actually delay or wait for a couple of blocks for it to finalize. And this is really important for systems where you have various consensus or various block times, i.e. other blockchains. And that's why I think asynchronous is going to be very powerful and very important for this. And of course, gaming example as well. Like, you cannot stop the block. That's the whole point of blockchain. If it halts, it's a huge problem. But with asynchronicity, you can achieve this more extendability and flexibility without having to halt the blockchain.
So Gears kind of integrated this model via the active model. Cosmosm's already kind of doing it over in Cosmos ecosystem. Does that kind of indicate that having these, having WASM in place, having this asynchronicity, it really unlocks the potential of having multi-chain communications? At the moment, things are kind of a bit handicapped in that area, but will this kind of really unlock the next level of interactions between chains?
That's where I'm betting on, yeah.
Yeah, that's true. I think that even more, that unlocks the even bigger power of the blockchain, because you can build more sophisticated programs on top of the blockchain.
Mm. Well, that's kind of going back to one of the problems of EVM, right? EVM is terminable. It has to happen in one block, and if the execution takes too long, it just gets it gets stopped, and it will fail. If it reaches the gas limit, it will fail. So yeah, it unlocks more complex use cases. I'm really curious though, like going back and you guys have been working on this for the past year. What are some of the lessons that you've learned on this journey of integrating WASM into Polkadot, into Substrate? What would you have done differently if you'd gone back a year or two?
That's quite hard to say. Well, I guess what I would have done differently is not work at blockchain, because it's really hard. For some
just work at Google or Mozilla and work on a browser.
Yeah, you know what?
Nice and easy.
I'll just use this resume.
You don't have to worry about anything about memory management of those kind of companies.
Yeah. But like, I guess jokes aside, like, it's really hard to say, because this is a collective effort. It's not just us working on it. It's multiple parties involved in it. So what I would have done differently is tech-wise, there isn't really much I could have done differently, to be honest. It's sort of, it was kind of inevitable where we are going and the way how we did it. But what I would definitely improve on is have a more, I guess, be more active and proactive when it comes to communication between projects that share the same interest, because there are a lot of projects who wants to go to WASM, but it's always the problem is, like, because there is no adoption, people are hesitant in going in there. But if people don't go in there, there is no adoption. So it's like the chicken and egg problem, and we need the first penguin to move. And here at Astar, I would say, like, we are one of the first penguins to move into the WASM, like fully commit to the WASM direction. But I would definitely be careful and like really ensure thorough communication with all the other interested parties, so that we can move together instead of just having us doing most of the heavy lifting when we have to do it.
Okay, from our side, actually, we're still on the part of the development. So I think that it's difficult to say what you would be doing like different. Obviously, if you already would know everything, then you will like take a shorter path, because, for example, last year we thought that we finalized some stuff, but we have to rebuild it because we understood there were several issues there, and it's better to do it from scratch rather than to try to fix that up. But I think that when you are building something new that nobody did before in this way, then it's always would be a point of trying and error. And the only thing that actually it's needed to be is to be persistent and to keep on working on that. And I think that's true regarding the something that I really like a lot from .sum ecosystem, that a lot of projects are actually open and willing to work together to build something bigger and more interesting. Because when we're talking about like Ethereum, what was the first, let's say, ecosystem, and has a lot of developers there. It has a lot of programs. It has a lot of users. So to bring the adoption into, let's say, Polkadot or WASM ecosystem, it's a little bit more complicated. But I think, as Hoon said, once we'll have the first programs working here, we'll understand that it's much more easy, and you can build much more sophisticated solutions that could be easier to use and more user-friendly for everybody.
Hoon, you mentioned something that I'd like to go back to. Astar is, you guys are kind of supporting, three different things, right? You're supporting both EVM and WASM, all on a substrate chain. That must bring in some huge amount of complexity. But how, is this a kind of a key tool here to kind of grow the ecosystem by kind of giving everyone an option to do whatever the hell they want and build it however they want?
Well, yeah, I guess you can say that, but the way how we see it is we consider ourselves like the gateway to the future of blockchains. And EVM is something that is widely adopted, and I do not think it's wise to force any new adoption because there's going to be a lot of backlash. We have to justify why WASM is far superior than the Solidity. And in a technical sense, it's easy to explain, but the user experience where it barely changes, and for the stakeholders or the business people, they do not see much interest in EVM. So what we want to do is we want to be like this transitional period or transitional platform where people with EVM can still deploy, use all the applications, existing applications to its full extent. We also provide WASM, and people can deploy new applications from scratch. But through XVM, people can have access to the existing liquidity of EVM, existing applications in EVM, and sort of interoperate with the WASM application, so they can incrementally improve their project by using multiple languages in multiple environments without having to go through like different blockchains and interoperate between the blockchains, right? And the idea here is that once we establish this gateway, we can see a lot of other future projects that fully focuses on WASM, that fully supports something new that only is possible in WASM, and use us as like a starting ground for their projects.
So it's about creating a safe environment for people to kind of experiment and slowly migrate from EVM to WASM progressively over time.
Yes, that's definitely a huge part of it. But I wouldn't say exclusively experimenting, but more like opening up the potential for people's imagination to go crazy, right? And they don't have to be afraid of going out of business.
Yeah,
it's like opening the door practically. What they're doing is making the first small steps to everybody that's already had the programs there. Just first try it here, then you can upgrade it, and then you understand that you don't need to keep on doing it with Solidity. You can do it directly on WASM.
Absolutely, and that's what the Astar is all about. We are the network where innovation starts.
And we've come a long way, right? WASM's getting to a point of maturity where you can kind of build and run these contracts in this execution environment on different chains. There's also, languages like Ink that are kind of optimized to run on Substrate. You got development tooling, a lot of other pieces, documentation's getting fleshed out. You've even got, indexes like us at SubQuery. We now can support indexing, WASM contracts and the outputs of those. So now we're starting to flesh out the developer ecosystem, the developer experience. What are one of the last few kind of building blocks or things that are kind of preventing the first big applications being built on WASM? Is there anything like left to be built or to be matured?
There's always work, of course. That's why
there's always work, of course.
There's always work, yeah. That's I like to call that job security, but no, it's like in exchange for my health. Yeah, jokes aside, when it comes to like what are the remaining blockers or what's the next step for WASM for mass adoption, right? To go into the EVM level. Well, first thing is definitely the interoperability, not just within the same blockchain for different environments, but also different blockchains. Unless we can really empower the smart contracts to leverage the powers of other blockchains and break this boundary, this notion of like bridges are insecure and interoperability is bad. We have to maximize blockchains. Like we want to remove that. And unless the protocol, for example, XCM, XCMP, unless those protocols are more mature, it's going to be a bit challenging to see like true powerful use cases that's only possible through WebAssembly smart contracts. And another thing is Ink 4.0. So this one is a real doozy, but it's something that's long overdue. But I believe Ink 4.0 is aimed to be released next year, early first quarter of next year, hopefully January. And this enables like contract verification and changes to the metadata and so much breaking changes. This sort of makes it hard for people to create production level dApps on Ink, the current version of Ink, because we know that there's going to be a breaking change in 4.0. So unless that is fully available, I do not expect people to like create fully commit to the WASM, or specifically the Ink variant of WASM at this stage.
What do you think, Pavel? Do you think there's any big blockers from your perspective?
Actually, I think that will be touch the big blocker on the previous question, that it's actually a game of the chicken and the egg. Till we don't have community that and TVL and money going into the, let's say, the WASM infrastructure, into the Polkadot into ecosystem, it will be difficult the developers to bring it here. So there's two ways how that could be done. First of all, yes, it's actually trying to make a bigger ecosystem and bringing like bridges and stuff like that, XML messages. The other one is bringing new people from outside to build something here, so that they could bring their own community and their own ideas. We're trying to run both of the ways. Let's see which one will work better. But yes, till we will not see more, I think more people and more products that would like to use and try or experiment with WASM, it will be difficult to bring this mass adoption.
Yeah, you're exactly right, right? It's chicken and egg, where it's a new technology and people want stability for their product. So you kind of got to help teams build the first version and then kind of slowly reach critical mass after that. It's a challenge we kind of know well. I think for all of our projects, right? But yeah, no. Let's I think anything else you want to add there? Otherwise, let's open up the floor for any questions. I believe Abe Astar is requested to talk. Let me just add you in or invite you in. And if anyone else has any questions, feel free to request to speak. Abe, can you speak? Maybe not. In the meantime, I've got one more actually. If we could bring out the crystal balls and peer deep into the Palantir. So I've been watching a lot of Lord of the Rings recently, and it's fresh on my mind. And look at 5 years' time. Do you think WASM is going to, and well, maybe not 5 years, maybe 10 years or whatever, but do you think WASM will replace EVM, or do you think they'll coexist peacefully into the future?
Well,
yeah, go on.
Okay, thank you. So EVM, EVM, or sorry, WASM replace EVM. I wouldn't necessarily say so, because thing is, EVM is just a standard, WASM is just a standard, two different messaging formats, right? You can still have an EVM implementation implemented on WASM, so they're not mutually exclusive. But when it comes to like general trend, like will future blockchains use EVM or WASM, I would say definitely WASM. Like in 5 years from now, I can imagine new blockchains. Whenever there's a new blockchain, it's always going to be WASM. It's always going to be WASM based, because it just makes sense. In terms of smart contract environments, a little bit tricky, but if what we are doing right now works out, then I can imagine that more people who never touch Solidity will come and start building dApps, and that will lead to more people thinking that smart contracts are not just for built with Solidity, but they can use any language to write smart contracts. And it's going to be like how, I guess you can say, like sort of how C# or Java or other languages slowly replaced the role of C++ in game development, because generally game development was done through C++. It was like the predominant language, but now C++ is still there. We have Unreal Engine that's mainly focused on C++, but new engines, new languages, people will start to prefer those languages instead of using the traditional one. That's how I see it.
That's good actually, because what you were saying, like if you take the crystal ball out and think from here to 5 years, I was like, in the side of my head was like, please don't ask when DOT would be $100. Please, this is the question that I don't want to hear now.
Should I buy now?
We're beyond that. but if you could message me privately your predictions on that, I'd happily take that.
Okay. So regarding the WASM and all this stuff, I think that actually we already are seeing that. If you will see the new blockchains that are actually trying to rise, they're actually practically using WASM rather than EVM. If we're not talking about the forks of Ethereum, obviously. But I think that actually, as Hoon said, yes, it would be practically like coexisting in the beginning. Projects and the ecosystem that Ethereum is having will be there still at a certain moment, but nothing is forever in this earth. So everything is evolution, has its evolution, and I think that we will see the beauty of WASM, and especially when we talk about asynchronous messages, and that actually you can already start moving from the term of smart contract into smart program, because you can have already practically like a microservice system running on the blockchain that's more sophisticated and interesting than the smart contract is. And I think that all the new tendency of gamified stuff and everything that will be coming will be more going into WASM and this type of messaging.
Yeah, we do a lot of work in SubQuery and the Cosmos ecosystems, and Cosmos has been a lot of coverage in the news recently. They've got a very similar, I guess, goal. The way they do it is slightly different from Polkadot, but the goals are kind of similar in terms of providing a great basis for a set of different application chains or parachains that all have their own specialty but talk to each other and speak common language. And the most of them that we talk to, I would say, 70% of them so far, they all use CosmWasm over Ethermint or Ethereum with the EVM, which really shows you where people over there see things going. So yeah, it's definitely got a lot of interest right now, and it's getting a large amount of adoption across Web3. Well, gentlemen, thank you very much for your time today. We ran slightly over, but it was an absolute pleasure talking to you about the ins and outs of WASM. Pavel, I don't know what you're talking about.